Morning, I'm Matt Frost from Google's Chrome Media team, and I'm here today to update you on efforts that we are undertaking within the team to improve video on the web, both for current use cases and for next generation use cases. So I'm going to talk a little bit about the current generation technology, which we're continuing to work to improve, called VP9, including an update on where VP9 stands in terms of support for HDR. And then finally, I'm going to talk about work that Google's doing with a number of high-tech companies to develop the next generation of video compression technology called AV1. And we're doing that work with a consortium called the Alliance for Open Media. As many of you probably know, and I apologize in advance, actually, we can't see our speaker notes, so some of these slides are taking me by surprise. As many of you may know, we started working at Google on these core media technologies back in 2010 when we launched a project called the WebM Project and open sourced a technology called VP8. Since that time, we've continued to work on this core mission, which is improving the vital video compression technology which powers web media. But we've also expanded what we're doing and started work on still image compression, on audio compression with work on the Opus open source audio codec. And then finally, with a recent project, we've started working on geometry compression with an open source project that will allow for efficient compression of things like meshes, which are used in video games, and point clouds, which are used when capturing environmental data with LiDAR or with devices like Tango. But as I said, what we really want to talk to you about today is our video technologies. VP9, which we are currently using very heavily at Google and constantly working to improve, and then this next generation technology, AV1. VP9 was launched back in 2013, and a lot of the press that VP9 has gotten has been around YouTube's use of VP9. YouTube was a very early adopter of VP9 and has been a very heavy user over the past 3.5 years. A lot of the narrative around YouTube's use of VP9 initially was about VP9 as an enabler of this new 4K experience and high frame rate HD experience. And current generation technologies like VP9 and HEVC are absolutely necessary to enable these cutting edge, high resolution experiences over traditional consumer broadband connections. One of the things that YouTube was able to take advantage of in order to launch their VP9 based service was the massive penetration that we had in terms of client endpoints. Almost immediately with the release of VP9, we added VP9 into Chrome. It was added into Firefox and Opera. Within a year it was added, or a year or so, it was added into Microsoft's current generation browser, Microsoft Edge. And so this gave us a huge platform of HTML5 video players that we could use. It was added as well to Android KitKat, opening up the mobile space for us. So we have, across all device types, billions of endpoints, of which hundreds of millions support VP9 in hardware. So the Samsung S6, I think, was the first mobile device to have support for VP9. VP9 was a requirement for YouTube certification for 4K smart TVs starting in, I think, 2016. And that requirement for support of VP9 in hardware now extends to all YouTube certified televisions, regardless of resolution. As I said, a lot of the narrative about VP9 has been around 4K and has been around these high resolution experiences. What a lot of people that we talk to are unaware of, though, is how heavily YouTube relies on VP9 down the resolution stack. So if you look, and all of this data is available if you just right-click on a PC, on a YouTube video, and click Stats for Nerds. So the 4K version of this video is available in VP9. The full HD version of the video is available in VP9. The 144p version of this video is available in VP9. And this is true for virtually all of the videos that you will find on YouTube, is that they are supported not only in H.264, which is kind of the working horse fallback codec, but also in VP9. And the reason that YouTube has worked so hard to make VP9 video available across resolution, supporting all use types, is because VP9 quality dramatically improves the YouTube experience. And it does so because it's 40 to 50% higher quality than H.264. Now, usually in sessions like this or in one-on-one conversations with partners when we're talking about quality, we talk about data that we get from tests using standard objective metrics. And those are metrics like PSNR or SSIM or derivatives of those metrics like fast SSIM. And so here we have a sort of traditional presentation of data around VP9 performance compared with H.264 for CIF resolution, which shows remarkable improvement over H.264. We can present similar data for VP9, contrasting VP9 performance on HD material with H.264 on similar material. Another way that we present this data and that we test the data ourselves is to encode a huge number of clips, taking advantage of YouTube's vast trove of user-generated content, which ranges from very highly produced cinematic type content to less highly produced, lower resolution, user-generated content. And so we spend a lot of time looking at videos encoded in the different formats, looking at still images of the formats in different formats, judging data rates of both, and making judgments about what sort of improvements we're seeing from generation to generation. But really, what we want to know is, does the new technology that we've created, does VP9 improve the experience of users who are using that technology when compared with H.264? And what we know from 3.5 years of experience with YouTube, where we've streamed billions of views a day in VP9 video, many tens of billions of hours over the 3.5-year period of VP9 video, is that VP9 starts faster because there's lower latency, it plays more smoothly because there's longer time between rebuffering, and it provides higher resolution videos. In general, where a user is limited in his or her ability to get the very highest resolution video available because of bandwidth constraints, we can bump users up one resolution. So for instance, from 720p to 1080p, compared with the user who's getting access to that same video in H.264. And what this means, and this, when we look at the most important metric that I think we in this room care about, it's watch time. What effect does moving from H.264 to VP9 have on watch time? And over this giant, essentially A/B experiment that we've run over 3.5 years, involving hundreds of billions of views of VP9 video compared with H.264 video, we know that VP9 video substantially increases watch time compared with users who are watching H.264 video. And this is true across the globe. In developed markets like North America, Western Europe, parts of Asia, where users have very strong home broadband connections, and we are already able to provide them with a really great experience using H.264, we still see modest upticks in watch time. But in that case, because there's really not that much that we can do to improve the user experience, what YouTube manages to do is pocket a lot of the savings from using a more efficient codec. But it's really in the emerging markets where users suffer from severe bandwidth constraints and are getting really marginal YouTube experiences where we see the most profound effects. And in those areas where we're seeing the next billion users come online in emerging markets like Brazil, India, and Indonesia, we're seeing tens of percentage points in increase in watch time of YouTube video compared with H.264. And that increase in watch time correlates directly to increase in advertising revenue for YouTube. So I think when we in this room think about the promises of a next generation codec, we all understand what codecs do. They compress video more efficiently and allow for storage in either a smaller space or distribution over the internet more efficiently or at a higher resolution. But really what we care about is this sort of business data. And we know from 3.5 years of use of VP9 video at YouTube, over all resolutions to users around the globe, that it significantly improves user experience, and that that has a direct effect on user watch time. One other thing that we look at as evidence of the quality that VP9 delivers is what other partners are seeing. As many of you may know, Netflix has recently started to speak increasingly publicly about their use of VP9. And their initial foray into VP9 has been actually in the mobile use case for lower resolutions. We tend to think of Netflix as producing a very high quality, high resolution experience, and most importantly being sort of a streaming experience. But Netflix, like Google, like Facebook, is very focused on emerging economies, and they have recently rolled out a download and play experience. And the experience that they're offering and the demonstrations that they've presented at Mobile World Congress and at NAB are showing a download and play at data rates between 100 kilobits per second and 200 kilobits per second of DVD quality video. And that's quality that was just unimaginable several years ago and is enabled by VP9. I participated in a conversation with Ann Aaron, a fireside chat on stage with Ann Aaron, the director of video algorithms at Facebook at NAB. And Ann was talking about their path to supporting VP9. And she said that initially when they heard about VP9 and heard the claims around VP9, they were skeptical about our claims of 40 to 50% gains over H.264 and of VP9's being on par with other current generation codecs. But after extensive testing, and I think what Ann called one of the largest codec tests ever performed, with taking advantage of a very sophisticated algorithm team at Netflix, the huge trove of content that Netflix had, she said that they too were seeing 40 to 50% gains in VP9 over H.264. So this is the other sort of information that we like to look at, is not just the tests that we do in the labs, using our best efforts to test against competitor technologies, but what other sophisticated teams in the industry are seeing around VP9 quality. One of the other things that has been encouraging has been Netflix's growing commitment to open source video. We recently announced that we had cooperated with Netflix and a third company called Idiom to optimize the VP9 encoder in the open source project called libit-vpx to speed it up and to improve multi-threading for faster encodes. So one of the things that's interesting about the way that Netflix is using VP9 is that we've been working with this partner, Idiom, to contribute improvements to the open source encoder. Idiom itself has a private source closed branch encoder that they license separately. And there's yet a third company, or I guess a second company, called Two Orioles, which was founded by one of the former members of our team, one of the key architects of VP9 named Ronald Bolchi. It's based out of New York, and they are a key provider of VP9 technology to Netflix. And Ann said in our discussion that they expect to see another 10% gain in VP9 compared with H.264 based on both algorithmic work that Netflix is doing, bitrate work that they're doing, as well as the work that they are benefiting from in terms of this Two Orioles encoder. So for those of you who are considering VP9, there are a number of solutions out there, ranging from the open source solution that YouTube uses and the other teams at Google are using, and then these closed source solutions that Netflix and other partners are starting to explore. One other thing I would mention for those of you who may be focused on video conferencing solutions or other solutions that take advantage of the open source WebRTC protocols that Google open sourced back at the same time we launched the WebM project, is that VP9 is seeing increasing use in the WebRTC space. Both our internal analysis based on data that we gather and external reports suggest that VP9 use in WebRTC has grown to almost 10%. And obviously what allows this is the fact that VP9 is present in all of these HTML5 browsers, which are the clients that are being used as development platforms for a lot of the web-based video conferencing experiences. And this growth to VP9 to closing to 10% is particularly interesting because it's entirely organic growth that doesn't come from Google, because we haven't launched any VP9-based WebRTC products right now. So this 10% comes from companies other than Google, which is quite interesting. The other thing we wanted to briefly touch on for those of you who are interested in these very highest resolution experiences, and in particular high dynamic range solutions based on VP9, is to just give you an update on where we stand. VP9 supports all of the features and hooks that are necessary to enable HDR. There are 4 VP9 profiles ranging from 8-bit 420 to 10 and 12-bit 422 and 444. What we see for HDR across all codecs is, in general, the industry is using 10-bit 420, so that would be VP9 Profile 2. And YouTube, which has an HDR solution that's based on VP9, provides that solution within the Matruska file wrapper. As those of you who are familiar with the WebM project know, the initial wrapper that was used with VP8 and VP9 video was based on the Matruska file format. And we have published an implementation of HDR metadata in the WebM file format in the Matruska file wrapper, and that's available on the WebM project website. Because there are partners out there who are interested in using VP9 with MP4, and Netflix is one of those, we've also gone to the efforts of publishing similar information about how to embed HDR metadata in an MP4 file wrapper. And that's work that we undertook with Netflix and Microsoft, had standardized through ISO BMFF, and again, that information is available on the WebM project website. And finally, in terms of transfer systems, we currently support both hybrid log gamma and perceptual quantizer transfer systems for VP9. So we offer essentially all of the possible solutions that you get with, for instance, HEVC as part of a VP9 HDR solution. And I would note that, and this holds true actually, I'm not going to talk about DRM, but this holds true for DRM as well. VP9 is just a codec. We use it with certain technologies, and at Google we tend to use it with Widevine DRM and with the WebM file format and with the Opus open source audio codec, but it can be used with AAC and PlayReady in an MP4 wrapper. It's just a codec. We're working with other providers of third-party HDR solutions as well, and we expect that we will see VP9 working with other HDR solutions in the not-too-distant future. So all of this information I've shared with you is available on the WebM project website, which has a host of resources for developers. The code itself, the SDK, which is in source code format, contains all the decoder source code, all the optimizations that we use for Android, for embedded platforms, as well as all the encoder optimizations that I've been talking about, are all available on the project website for download. And then finally, our marketing team and developer advocacy team has spent a lot of time over the last year working on developing better developer resources, documents that do a good job of describing how to get the best possible performance out of VP9, and that's all available on the Google Developers website. So finally, I want to give you an update on what we're working on next, the next generation technology, which Google and other partners will be releasing. As some of you may be aware, back in 2015, we announced the launch of a consortium called the Alliance for Open Media. And that effort really grew out of conversations that we were having back in the 2014-2015 timeframe as we went out and talked about VP9 and especially about YouTube's plans to use VP9 heavily with partners in the tech world. And what we found was that there was an increasing openness to working together on developing codecs that could be rapidly implemented with license terms that were easy to understand, and cooperating on developing technologies that we're all going to use in different ways, but that acknowledges the fact that in this world we all have the same technologies, and it makes sense to cooperate to develop those technologies quickly so we can all then build product and services that benefit from these better technologies. We brought together a great group initially in 2015 when we launched, and we've added a number of significant tech partners since then. And I think what I would point out about the team that we've assembled is that it includes all of the companies that were working on open source video codecs: Google, Mozilla, Cisco. It includes old line companies that were there at the very early stages of codec development, like Intel and Microsoft. And I think most importantly, it includes companies that control the most significant, many of the most significant providers of internet video right now, with YouTube, Google Play, Netflix, Amazon Prime, Twitch, Hulu, the BBC. So these are all companies that have come together to set the requirements for AV1, this next generation codec, and to help us work together to try to get this technology out as quickly as possible. The mission of the Alliance for Open Media remains the same as the mission of the WebM project that we launched back in 2010. And that's to provide free open source video technology for the web, to make sure that it continues to improve as quickly as possible and is cutting edge, producing quality that's as good as the best video technology that's out there, and that it provides an alternative to the standards, that we achieve this rapid innovation by breaking free of the traditional standards process, which involves quarterly meetings at sites around the globe, and that pulls engineers who are involved in this process away from their teams and from their desks for well over a month of a year for travel time and meeting time. The benefits that we see in this open process is that it's a collaborative process, that we've brought together not only device manufacturers, not only web browser developers, but also the content creators, the teams that are actually going to be using these technologies. So we are developing close to the real users, close to the companies that are producing new video experiences, close to the companies that are encoding in these new formats. And again, that we are developing at pace with creation of new experiences with video. One of the things that we tried to do back when we launched the WebM project, and that we've continued to do with these partners in the Alliance for Open Media, is to treat codec development more like a software development process, to iterate in software, to develop in software, and then to capture what we've done in software, the rapid improvements we can make in software through bitstream specifications that are then made available to companies that want to provide new implementations, whether they're hardware implementations or independently developed encoder implementations. And again, obviously, an end goal is a codec that is significantly higher quality than previous generations. So in this case, a step ahead from VP9 and HEVC, while maintaining comparatively low complexity. So in general, we will take a 1% increase in quality for a 1% increase in software-based decoder complexity. Because we recognize if we're going to iterate quickly, if we're going to get new codecs out quickly, for the first year or a year and a half, those codecs are going to be software-based codecs, and they have to be manageable by the processors that are out there in the field. Obviously, if we have an open source codec, we need to take very strong steps and be very diligent in making sure that we are in fact producing something that's royalty-free. So we have an extensive IP diligence process, which involves diligence at both the contributors level. So when Google proposes a tool, we are doing in-house IP diligence using our in-house and patent assets and outside advisors. That is then forwarded to the group and is then again reviewed by outside counsel that's engaged by the Alliance. So that's a step that actually slows down innovation, but is obviously necessary to produce something that is open source and royalty free. And then finally, one of the goals is to produce tools and to produce code that is easy to implement, to really take advantage of what we've been trying to achieve with HTML, and to produce tools that don't require dedicated codec engineers to implement, but that competent video professionals, competent coders can easily build into new video experiences. And this is especially true as we start to do everything we can to make sure that playback is easy in HTML5 browsers, which provide such an important platform for playback now. And in the session following me, Hussein Bengali, who's also from the Chrome Media team, is going to be talking about work that we're doing around progressive web apps, which are an attempt to provide the same benefits of native applications in the web platform. So in terms of an actual update on where we are with AV1, it's been an active development since 2015 when we brought together Google's efforts to develop VP10, what was going to be the successor to VP9, the Mozilla efforts and the Cisco efforts, which have now all been merged together. The goal, as I said, is significant improvement over prior generations. What we're looking at is a 40 to 50% improvement over VP9 and HEVC, which we consider to be state-of-the-art for current generation codecs, and then to pave the way for rapid adoption. So one of the things that we're doing is we are making sure that we have all the tools that we know from long experience of rolling out codecs are necessary to allow device manufacturers to rapidly adopt. And these are things like hardware designs, which chip manufacturers can easily implement on their chips. Highly optimized ARM and GPU optimized libraries that can be used as a first means of support for VP9 on embedded platform, AV1 on embedded platforms. So for those of you who are interested in taking a look at what we're doing, and I would say that this is all source code that I'm pointing to you. This is experimental code that requires a good deal of knowledge to integrate and implement. But the code is out there, and you can go out and look at our check-ins and see what we're doing on a day-to-day basis. And for those of you who have the ability to go out and build, you can build it, run configs, and run the experiments that we are running to see what sort of quality gains we're getting. In terms of adoption, YouTube's going to follow the path that they took with VP9, and that is start to support AV1 virtually the day that it is released. They'll be able to do that because we expect to see very rapid support for AV1 rather, in HTML5 browsers. Chrome will be experimenting with AV1 in all likelihood prior to final freeze of the bitstream specification. Obviously, we have Microsoft and Mozilla also as members of the Alliance for Open Media. Netflix has said publicly and on a number of occasions that they plan to be very early adopters of AV1. Their goal, I think, is to do much the same thing that YouTube is doing, which is start providing AV1 streams virtually the day that AV1 is frozen. And the AV1 ecosystem is gearing up, and that means for all the tools that are necessary to provide support for AV1, these are low-level testing tools for hardware companies and for companies that are producing independently produced decoders and encoders. We've got testing tools. We've got companies like Idiom producing software optimized tools for AV1. At NAB, there were 2 or 3 demonstrations of AV1. Bitmovin that's here today had a demonstration of real-time AV1. Idiom had a demonstration of 4K VP1 compared with, I think, HEVC. So the industry is gearing up to support AV1. Obviously, our delivery by the end of this year is very heavily dependent on 2 things. It's our continuing to get the gains that we need to get from where we are currently, which is maybe 30 to 35% for all the experimental tools that we have in the code tree, not all of which have been adopted by the working group. I think Ann Aaron said that they were seeing about 20% gains for the adopted tools. So those are tools that have been through the technical analysis of the broad alliance team. So we still have to make up that last 10% 15% in gains over the intervening period. And then we have to get it through our IP review process. And there's always a possibility that we'll say we're uncomfortable with one tool, we want to pull it out, and we have to fill in the gap in terms of quality from pulling out that tool. But things are looking very good, and certainly there's a ton of excitement around AV1. And so we encourage you all to keep track of what we're doing in the open source project. If you're interested in building it, do that. And we hope to have another update, maybe at Streaming Media West later this year, on where we stand. Thank you.